on migrating on-premises SQL Server databases to the cloud. We'll be uploading a copy of the presentation to SlideShare and YouTube tomorrow morning. All participants will be sent up a follow-up email that includes a link that will allow you to download a copy. This month, Jim Donahoe, one of RDX's cloud migration experts, will be migrating an on-premises SQL Server environment to Azure SQL DB. In addition to the live migration, we'll learn the different migration methods and tool sets available and how to choose the deployment mechanism that best meets each application's unique migration needs. We'll finish the webinar by describing how to correct the most common errors that can occur during the migration process. Jim has performed dozens of migrations to IaaS and DBaas and will be providing his recommendations and best practices to ensure your transition to the cloud is trouble-free. By default, GoToWebinar mutes all participants except the speaker, which is a good thing because it reduces the chance of background noise affecting the presentation. We're going to hold questions until the end. There's a button on the GoToWebinar panel that will allow you to type your questions in. Kelly, who's the webinar's organizer, will bundle them up and we'll discuss them at the end. We want to be respectful of your time. We know that many of you will have meetings right after this one. I've timed the presentation to allow a Q&A at the end, but if we're in danger of running over, I'll respond to the remaining questions by email. Well, in this case, Jim will because he's our tech expert. You'll need to mark your calendars for RDX's next Insight Series presentation. On Thursday, May 24th, Jim Donahoe and I will be presenting Azure SQL Managed Instances. Once again, since Jim's the tech expert, he'll be doing most of the talking. Microsoft recently unveiled Managed Instances, which combines the benefits of Platform as a Service with the ease of migration and increased control provided by Infrastructure as a Service. Jim will be putting Managed Instances through its paces very soon and will provide us with his analysis. I also distribute a monthly newsletter that you might be interested in. It covers a wide array of tech topics that we think would benefit readers both personally and professionally. You don't have to be a customer to receive it. If you'd like to be added to the distribution list, let me know. I'll display my email on the last slide of this presentation. You can always add me as your LinkedIn buddy. I write articles and SlideShare presentations on a lot of different wide-ranging tech topics. So let's get started with today's presentation. I'm not showing this slide as a cheap advertisement for our services. What I'm attempting to show is that RDX has experience monitoring and administering a wide range of environments. We support thousands of databases and operating systems. This includes cloud IaaS, DBaas, on-premises, relational, NoSQL, commercial, and open source database products. One of the benefits that RDX can provide all shops is our wide range of expertise. It's just the nature of our business. We support close to 600 customers who are not constrained by any one shop's tech stack. We are required to administer virtually every database feature you can think of for every product we support, and we work with dozens and dozens of tech stack combinations. We support most IaaS offerings, which you all know is just a server in the cloud. We also support Azure SQL DB, Amazon RDS, and Oracle's Cloud DB platform. The cloud platform that's garnering the most interest from our customers is Azure, followed by Amazon, mostly MySQL, PostgreSQL, and then Oracle. Because of our large customer base and the number of supported servers, we're a good bellwether for the adoption rate of different technologies and support strategies. We've created a robust set of white papers and webinars on our cloud migration services and case study success stories to market our services. You can find them all on LinkedIn, YouTube, and SlideShare. Just do a search for RDX on those sites. RDX is positioning itself as the go-to vendor for cloud DBMS migration and support services. Our key value prop is it's not just our expertise and experience in cloud migrations and support. It's also that we have experts in the source and target database platforms. SQL Server on-premises migrations to Azure SQL DB, MySQL on-premises migrations to Aurora, Microsoft MySQL Cloud, or Oracle's MySQL Cloud. We have dedicated database product experts on both sides of the migration, source and target, which provides a huge value to the project. Here's what RDX has learned over the last few years supporting cloud database management systems. They're certainly increasing in popularity. As they do, requests for our services are also increasing. Cloud environments are architectures, not just database products. Depending on the vendor you choose, the complexity of those architectures and the way you administer them can range from very simple IaaS platforms to extremely complex multi-cloud DBaas environments. Some databases work better in the cloud than others. One of the challenges we have to evaluate is exactly how much data do we want to transfer back and forth in that architecture? How much data and how long is it going to take? In addition, we'll need to determine if our vendor offering charges us for those transfers and how much. Does the database interact with other systems? A popular feature in any DBMS is using its inherent linking capability to access data in other systems. You can use a single SQL statement to access one database and then use links to join that information to the data residing in other databases. Will those other databases be on-premises or will they also be in the cloud? Does it generate a lot of output? Do you use that database to refresh other systems? Does it generate large reports or flat files and other data streams that are used as input to other applications? What features does the database use? You'll need to verify that all the features utilized in your on-premises SQL Server databases are available in Azure SQL DB. If you use a particular feature that is not available or Azure SQL DB provides like functionality, you'll need to determine how big of an impact that's going to be. We also need to analyze all the software that interacts with the database, application software, utilities, monitoring, security. Will they continue to work in a cloud system? Does the database use any highly available features? How critical is it? What are its backup requirements? How many copies of your backups do you need to retain? How big is it? How will you initially seed that database? Security. Is the database governed by internal, industry-specific, or governmental regulations? DBaas environments don't have the same level of visibility as IaaS or on-premises. You'll also need to estimate the processing workloads. You're going to be renting that environment, and the cloud provider will charge you based on CPU, memory, I/O, and disk storage. Are your workloads fairly predictable, or do they have large fluctuations? If they fluctuate heavily, Microsoft has an excellent alternative. Azure DB allows you to create elastic pools. With a single database, you estimate the amount of resources that the database requires to handle its workload. SQL database elastic pools allow you to combine multiple databases and their workloads into a group, and then allocate shared resources to that group. This is especially beneficial for databases that have spiky workloads. You may have systems that are hit heavily throughout the day and a different set that's accessed by nightly batch jobs. The more databases you can add to a pool, the greater your savings become. The fewer databases that peak at the same time, the lower the pool resources can be set and the more cost-effective the pool becomes. We need to estimate how much work it's going to be to migrate that database to the cloud. Your options can range from lift and shift with minimal changes to a total application rewrite. You may have outdated apps that you want to rewrite from scratch. What we need to remember is that no database is an island. As I said, they take feeds from flat files and other database applications and produce output that is adjusted by other applications and end users. Getting a lot of data into and out of a Cloud DB system can be challenging, especially if there are tight time constraints and large data volumes need to be transferred. We've had several customers find that the different cloud offerings don't support the exact same features as their on-premises counterparts. This isn't a Microsoft-specific issue. It applies to all on-premises database products that have cloud counterparts. Since our demo today is migrating SQL Server on-premises to Azure SQL DB, let's take a look at the differences between these two DB products, both offered by the same vendor. I'm not going to go into each and every one of these, but here's the tech differences between Azure SQL DB, DBaas, and SQL Server on-premises. The features listed on this page do not exist in Azure SQL DB. If you currently use SQL Server on-premises, you'll need to be aware of these differences before you begin migrating databases to the cloud or creating new DB systems in Azure SQL DB. This list can always change, but you'll always find a current list of differences in the Microsoft documentation for Azure SQL DB. I've provided a link to the documentation at the bottom of this slide. I'm not stating that these environments aren't as effective as on-premise. They just have different features, and we all need to be aware of those differences. Some of these feature mismatches are complex, and it can be a challenge to leverage the like functionality provided by Azure SQL DB. DBAs and developers are often required to work together to come up with a viable solution. Now that we've selected our database or databases for migration, let's take a look at the high-level steps we'll perform. Planning for a cloud migration is like any other tech project that's complex and has a lot of steps. You'll need to dedicate time to educate your team in the cloud target you've chosen. You'll want to become familiar with how the data is stored, how your applications will connect to the cloud database, how it will be administered, monitored, secured, audited, backed up. Does your team know how to recover the system? Will you be implementing HA&D or architectures? Are there any feature mismatches you need to plan for? How will you transfer data back and forth to that cloud architecture during daily operations? Can your network and cloud connection handle that increased volume? You'll also need to determine if you want to migrate the database to the cloud in one step, or you want to seed it, then keep it in sync until you're ready to perform the final production cutover. Some of these steps I'm showing may be combined or removed entirely. Depending on the mechanism you choose, you can migrate the database structure and the data at the same time. You may choose to migrate the database data and cut over after you have verified it's been successfully moved to the cloud without setting up synchronization. What steps will you perform to verify that the database has been successfully migrated to the cloud target? At the end of this planning phase, you should also be able to more accurately estimate the level of effort required to migrate the database to the cloud. Your project document will include the mechanism you've chosen to upload the database to the cloud. In addition, it will document the steps you will execute to perform the migration and verify that the process has completed successfully. As I stated when I started discussing this slide, cloud migrations are much like any other tech project. Robust testing and verification will be critical components of your project plan. All the leading cloud database providers want to make it absolutely as easy as possible to migrate your on-premises databases to their architectures. There are several strategies and mechanisms you can choose to initially seed the cloud database with your on-premises data and then keep the systems in sync until you're ready to perform the production cutover. The mechanisms you choose to migrate the system will depend on several key factors: the transfer, conversion, and sync tools available from the vendor, in this case, Microsoft. How much data will you be migrating? And the acceptable outage length. Can the system be down? If so, how long? Let's take a look at some of the Microsoft utilities. Data Migration Assistance. We're talking about DMA. It scans your source database and detects compatibility issues that can impact database functionality on your new version of SQL Server or the cloud Azure SQL database. So it covers both upgrades and cloud migrations. It recommends performance and reliability improvements for your target environment. It allows you to not only move your schema and data, but also uncontained objects from your source server to your target server. The utility allows you to evaluate the on-premises SQL Server instances you are migrating to Azure SQL DB. It will identify compatibility issues that may prevent the successful migration from SQL Server on-premises to Azure SQL DB. It then provides recommendations to help you remediate those issues. We learned previously that although the Cloud DB system may not have the exact same features as its on-premises counterparts, it has features that provide similar functionality. DMA detects partially or unsupported features that are currently used in the source SQL Server database. It then provides a set of recommendations, alternative approaches available in Azure, and the steps that can be performed to implement them. Microsoft's Data Migration Services. Now we're talking about DMS. It uses the Data Migration Assistant to generate assessment reports that can help you identify the necessary changes. But you'll be required to implement them. It doesn't automate that part of the process. When you're ready to perform the migration, the Azure Database Migration Service automates the conversion activities. The next few slides contain screenshots and additional information on DMA and DMS. SQL Server's transactional replication can also be used to migrate your on-premises SQL Server database to the cloud. You can configure your on-premises SQL Server database as the publisher and configure your Azure SQL database as a push subscriber to that SQL Server instance. The transactional replication distributor synchronizes data from the publisher to the subscriber. All changes to your data and schema will show up in your Azure SQL database. Once the synchronization is completed and you're ready to migrate, change the connection strings of your apps to point them to your new Azure SQL database. Here's a screenshot of the DMA output. It shows a few of the issues that's identified and the recommendations to correct them on the right. It will certainly help you to identify some of the issues that may affect the cloud migration process. You implement the recommendations and add additional emphasis to these line items in your migration test plan. Here's a screenshot of the schema conversion panel in DMA. You choose the source, target, objects you want to be migrated to Azure SQL DB. You hit the Deploy Schema button to perform that schema migration. Here's the Data Migration Service utility. You create a database migration service in the Azure portal, create a migration project, specify source and target systems, and perform the migration. I think one of the big benefits is that not only does it take care of the data migration, it provides you with recommendations during the configuration process. So we're finally ready to present what you all have been waiting to see, a live migration from a SQL Server on-premises system to Azure SQL DB. I'd like to introduce Jim Donahoe, RDX's top migration expert. Okay, Jim, I'm going to turn the controls over to you here. I'm going to do that now. Make presenter. Yes. You should have got a notification that to take control. Oh, there we go. Looks like you have them. Penny, how's the screen look? Good?
Yes, I think it looks great.
Okay, Jim, it's all you get.
Okay, well, thanks for the introduction there, Chris. Hello, everybody. Good afternoon, good morning, good evening, depending on what time zone you're in. My name's Jim Donahoe, as Chris has introduced me before. Before we get started, just wanted to show you a little bit about me. I'm the current Idera Ace. If you're not familiar with Idera or their products, they make a very good monitoring product. They sponsor me to go around the country and speak to different events. I'm a DBA. I do not fall under a normal category of database administrator. I like to think of myself as a does about anything. I'm a cloudy. I collect retro video games, which is why I have video game enthusiast. I'm a nerd. I don't work with so big data, and I'm a huge Azure enthusiast. For today's demos, you're actually going to see how I got involved with SQL to begin with. I started out as a junior DBA, and the reason why I got that job is because I wanted a database to track my video games that I collected throughout the years. So we're going to work with two different databases, Nintendo and Sega. Since I'm a child of the 80s, those were the only systems that were back then, that were around back then. So enough about me here. Let's move on. So what I'm going to talk to you about today is what are backpacks and DACpacks, some common deployment methods that I've used, and some common errors that I've encountered. The first one we're going to cover is what is a backpack? I won't read the slide to you. A backpack is essentially a SQL backup, right? As a DBA is a .bak is what your usual backups are. But for Azure, we want to call them a backpack. And we're going to use a backpack deployment today for all of our demos. I will show you what a DACpack looks like if we get time later through the demos. It just depends on how well Azure is behaving today. A DACpack is exactly what a backpack is without the data. It takes your schema and your database objects, instance objects, which include your logins that are associated with your user's database. It's very simple. I like to use DACpacks for clients that are just creating schema in the cloud. They don't need the data. Maybe they're just standing something up to use for a quick test, and they don't need all the data. They just want the basic framework there to use. I like to use DACpacks for those. So the deployment methods we're going to go through today are we're going to use the DMA, which is also known as the Microsoft Database Migration Assistant. I'm going to show you transactional replication, and it's nothing fancy about it. If you're familiar with transactional replication, it's just good old-fashioned replication. The same rules that apply on-prem do apply to the cloud. The big one being every table needs to have a primary key, right? You will not be able to replicate your database if it does not have a primary key in the table. You will not be able to replicate that table. It has to have a primary key. And the last one will be the Management Studio deployment. So one of the better things I like to say about the Management Studio one is it's not a very good method to use. And I will show you why in the demo. For the purposes of the first demo, we're not going to see these error messages I'm showing you now, but these are some common errors that I've encountered when I've done demos before, or when I've done deployments before, I'm sorry. As you can see, I have Mario there with game over. Usually if you get these errors on your deployment, it's game over, start over, right? Well, not so much. I'm going to show you a way to get around these common errors. The first one being this procedure has an unresolved reference to an object. External references are not supported. Well, what's that mean? It means you can't do a cross-database query inside of Azure SQL Database. But I'm going to show you a way around it. And the second one here, for the element login, Windows login property, you can't use a Windows login in Azure database. Some people might say, well, there's Azure AD. Why can't I use that? You can use Azure AD, but it does not take the Windows logins that you log into on-prem, right? So if you're using Windows authentication and you have your users logged in with Windows authentication, you cannot deploy those users to Azure DB. You'll have to drop them. So enough talk. Let's see some demo, right? That's what everybody's here for. Everybody's giving up their lunch hours for. So we're going to start with our Sega database. So this is my database service platform. Just so you know, there's only 3 databases here. And you guys can't see me doing it, but I'm showing you right now there's nothing up my sleeves. There's no magic going on. I'm going to refresh the screen here just so you know. There will only be these 3 databases on here for right now. There should be AdventureWorks, Nintendo Replication, and Sega once my internet picks up and works. Here we go. Those 3. So with the Database Migration Assistant, we're going to start a new project. Now, this is a free tool. You can download it just by Googling Database Migration Assistant. It's a very small package, but it makes your life so much easier when you're doing these deployments. You will see what I'm talking about. We're not going to do the assessment. We're going to do the straight migration. An assessment would be everything but moving the data. It's going to look at my database. It's going to compare it. It's going to look at the schemas. It's going to look at all the objects, make sure I'm not using anything that's incompatible with Azure. This is a good thing you want to do if you're planning on the move, because then you know what you have to fix, what you can fix, and what else you can use. As Chris hinted to before with managed instances, Microsoft is going to be bridging that gap between using infrastructure as a service and platform as a service, which is database as a service. Right? With managed instance, it's going to bridge that gap and you'll get more of the features there. However, we don't have access to the demos yet for that because of it's still a preview feature. So with this, we're just going to do the migration real quick. We're going to name my project. I'm going to call it Sega. Another quick note that if you're going to migrate a database to Azure with the Migration Assistant, the database has to exist on the Database as a Service instance already. It will not create the database for you. It has to exist. So you'll see on my on-prem here, under Sega, I have tables. I have 4 tables: Sega CD, Sega Genesis, Master System, and Sega Saturn, right? If I show you the tables under my Azure database, you will not see those same tables. It is a blank database. It does take a little longer to load. Again, it's connecting up to the Azure cloud. I am working remote, so my internet is not as fast as it would be when I'm in the office, but we'll do what we can here. So you see, no tables, nothing listed. Again, there's no magic up my sleeves, I promise. So back to our migration assistant. My source server type is a SQL server. My target server type is an Azure SQL database. My migration scope, I can do schema and data, schema only, or data only. Since my database is completely empty, I want to do schema and data. So I'm going to hit create, and I'm going to start going through the motions here. So here's my local machine where my database exists. I'm going to use my Windows authentication type because I am a Windows user. Connect. I want to choose my Sega database. I'm going to hit next. My server name. And this is going to be my target. My target is going to be my Azure Database as a Service instance. So I'm going to choose my database platform. There's my username. I got to copy my password in here. And we're going to hit connect. So here's all 3 of my Azure databases that exist at this point: AdventureWorks, Nintendo Replication, and Sega. I want to choose Sega. Next. It's going to ask, the next part is going to be, it's going to ask me what objects do I want to migrate from my source database to my target database. So what it was doing at that small point there was it's getting a list of all the objects. So you'll see here, And I apologize, I can't really zoom in on this. And if it's a little hard to see, I apologize. But I have my user accounts. These are database user accounts. These are not Windows logins. My tables, I have my 4 tables selected. And I have a simple procedure here, right? If you click on the object, it'll tell you there's no issues found for this object during assessment. This is good. This is what I want to see. No issues found, right? So we'll expand all these out again. So I'm going to generate the SQL script. This is just a script to create the schema in this is just a script to deploy my schema. This is not deploying anything yet. This is just giving you the script. So if we scroll through here, we see it's creating this table with my stored procedure. Sega CD is creating that table, Master System, Sega Saturn. Here's all my users, and it's granting connect to all of them, right? So I can either save this for a later time, or what I used to like to do is I used to save these scripts just in case I never have to do this again later. I wouldn't have to go through this whole motion again of creating the new project, selecting my target, all that. I can just save this script. Or if you're using an automation tool, like let's say Jenkins or something, and you want to create an artifact, you can just deploy it right from here. So I'm just going to hit my deploy schema. And my databases are not that big, thankfully. So we see all success. So all my schema is now at the Azure database. So if I refresh my database now, I should see my tables, and there they are. But there's not going to be any data. There shouldn't be any data, unless it did some kind of magic that I'm not aware of. There should not be data, and it will take a minute because, again, my connection is probably not as fast as an Office connection, but we'll see. There's no data in here yet. So we're going to migrate the data next. So you'll see here the tables. Here's our record counts. I have 884 rows in Sega Genesis, 652 in Saturn. So this table will probably take the longest. Again, these aren't big record sets, so I'm assuming probably about 10 seconds at the most. So we're going to hit Start Data Migration. Here we go. So the status is spinning. We should start seeing progress here, but since my data is so small, it's probably just going to go complete. Here we go. It's all completed. And I was pretty close. 5, 10. I was off by 8 seconds, but we'll call that a win. So if I go back to Management Studio now, and I do a new query, let's just do select top 1 star from Sega Genesis. And if you're not supposed to type during demos, but I think I can get away with it. And there we go. I have data, right? So now my database is this Sega database has been migrated from my local instance to Azure. This database is ready to use an Azure SQL database. So I always delete my projects when I'm done. So I'll hit yes, and I'll close this out because we are done with the migration assistant for our demos. The next database we're going to work with is our replication database. And you know what? I'm going to close this out because you guys don't need to see that part yet. So if you're familiar with replication at all, here's my local box, this Donahoe home. I am going to choose replication. This is one I was testing with, so let's just delete him real quick so you guys can see that there's no special things going on. Okay, so I will keep the publication created just, again, for the sake of time. So the Nintendo replication, I'm going to be replicating my Nintendo replication database. So here's all the tables in my Nintendo. There's GameCube, N64, NES. And again, if you're a child of the 80s, you probably know all these systems off the top of your head. I don't have any of the handheld systems listed just because that was a lot of data for me to put through. But for our purposes, I've just got the main consoles. If I look at my Nintendo replication database on Azure, none of these tables are listed. Again, we got to wait for it to expand. This is always the fun part during an Azure demo is waiting to see how long it takes. Well, they are there. You know what? Let's change that. So I'm going to run my PowerShell. I am going to delete my database first. These PowerShell scripts will save you. I love using these. These are a lot faster to do compared to using the portal for anything. I will send my scripts to Chris once the demos are over, in case anybody's ever interested in using these. So my database deleted before, I am now recreating it on the same server. And once it's there, we'll be able to set up replication, and you'll see there is no tables listed on that server. Now again, what's transactional replication? It's just traditional replication that we have today. I will show you the publication here, the properties. Here's all my articles selected. I have all my tables, and I have a few stored procedures. Okay, I have no filtered rows. We will take a snapshot. It's going to be pushing it here. For my security, it's not best practice, but I'm going to be using the SQL Server agent account. Okay, my database has been created. So let me refresh this one more time. And if I go into tables, we should not have tables. Once again, we wait for Azure, and it's always fun waiting for Azure. And there we go. So there's no tables listed. So we know that this is a fresh database. It's completely blank. So I'm going to create a new subscription here for my Azure database. I'm going to hit next. I want to keep all my agents at the distributor level, which is my local machine. I am going to add my new subscriber, which is my database as a service platform. I'm going to connect up. Now you'll notice if I hit the drop down here, you don't have the option to create new database. With Azure replicating to Azure SQL database, you don't have that option. The database has to exist already. I want to choose Nintendo replication. I'm going to hit next. Here's our connection information. Again, I wanted to use my SQL Server agent account. To connect to my subscriber, I got to put in my login info. And I'm copying this from my password repository. I hit OK. We're going to hit next. I want it to run continuously. It is transactional replication. I want it to replicate as often as possible to keep the copy updated. I want it to initialize immediately. Next, we're going to create our subscription. Yes. Some people like to save the script. For the purposes of this demo, I'm just going to do it this way. I'm going to hit finish. We'll wait for it to create. Okay, success. Yay. All right. So now I have my subscription to my database as a service platform for RDX. Let's view my synchronization status. So it's starting the agent. What this is doing is it's getting the snapshot information. The log reader is going to read the information. It's going to push it up. So it's applying my scripts. Now, this database as well is not a big database. This should not take long at all. So I'm going to refresh this one, and we should actually see our tables listed. And there we go. These also will have data. Let's just make sure the monitor is done. Okay, 4 transactions with 129 commands were delivered. Pretty cool, right? Now this is just my connection at home. I wouldn't call it a very stable connection, but it was pretty fast, right? Again, it's going to always depend on your network speed at your office or your co-location, and it's going to depend on how many objects you're pushing and how big they are for this initial setup. I've seen it take as long as 12 hours to do the initial snapshot, depending on how large your data is. So if I just do, let's say, since I'm a big Nintendo nerd, let's just do select star from NES titles, where name like, oh, we put this because it's not normal, because I made my database, I didn't know much. And we're going to put Mario. So many games I have with Mario, right? There we are. All my data has now replicated up to Azure database, right? So that's pretty cool. That's transactional replication. It's pretty simple to set up. And again, if you're familiar with it on-prem, you should be familiar with it in the cloud. The same rules apply. So the last one I want to show you is the least favorite method in my opinion. This one, we're going to use Management Studio to deploy our database directly to the cloud. When we're going through this process, you'll see why it is my least favorite method, because it's traditional SQL. It's either all or nothing. If it fails, you have to start the whole process over again. I do have a failure in here already just because I wanted to show you how to fix these. You'll see here, since it's a Nintendo database, we're going to blame it on Sonic. We're going to say Sonic broke my query. This procedure does nothing more than selects data out of my Sega database, right? So we're just going to hit execute, and we see return data here. Now the problem we're going to have is Azure doesn't support cross-database queries. So I'm going to do tasks. We're going to right-click on our database, choose tasks, deploy database to Microsoft Azure SQL Database. You hit next here, and we're going to start specifying our target information. So the server connection is going to be, what server do I want to connect to? Now you're going to notice my normal Nintendo database does not exist here whatsoever, right? It's not. You can even look at here from here. You can even look at the instance from here. Go back to overview, just force a refresh. It's just those three. So I am going to go back into Management Studio, bring up my wizard. We're going to connect to our Database as a Service platform. I'm going to hit connect. We'll leave the database name as Nintendo. I want it as a basic database because it's a small database and I don't need to drive the Azure spending bill up for my video game habits. So we're going to keep this under a gig. This part's important here. I want to focus a bit on this part. Temporary file name. This is going to be the location where your backpack of your database is created. Depending on the size of your database, you need to have that amount of space on the drive that this file is created on. Normally, it's going to choose the default directory wherever SQL Server is installed, right? Well, we don't want it there because if you're like me, your C drive is much smaller than your other drives you have. So my C drive has 530 gig, which for my Nintendo database is more than enough space. But let's say I had a bigger database that had financial data or anything. Let's say it's 500 gig in space. That's going to put my drive pretty close to capacity. I'd rather not do it. I want to choose my F drive, and we're going to use my RDX demo. And you can see a few of them that are already here that I was testing with. I'm going to leave the name as default because all this is a timestamp, 2018, 4/12/14. 2018, 04/12. And then here's the time, 14:36:31. So when this started, it was 2:36 Eastern time. I'm going to hit next, and it's going to be a little bit of a delay. What this is doing is it's checking my database on-prem, and it's making sure I can connect to the cloud. There's really nothing else going on at this point. It's just checking to make sure that everything I've specified in this list is good, right? It's checking file space. It's getting the database ready for deployment. And here's the summary of what we're going to do. Here's my source, my home machine, who I'm connected in as, the database that's going to be moved. My database is 18.8 megabytes. So again, it shouldn't take long. And it says, note that the deployed database might be larger than the target. This is true. It depends on what objects you have. The target is going to be my database as a service instance. I am connected with that user. It's going to create that database name as a basic database, maxes of a 1 gig size. And here's where it's going to put my backpack. And it tells you how much space is available. I'm going to hit finish, and you're going to see it pop up here where it's going to, start exporting. But it failed. Well, why did we fail? Let me take a look at the error. Now I can barely read it, and I'm 3 feet from the screen, so I know you're going to have trouble reading it. So I'm going to copy the message text. And we're going to go to my query window here, and you'll see why it failed. One or more unsupported elements were found in the schema, and it was Sonic broken. That darn Sonic, once again topping Nintendo, right? And it was a stored procedure. So to fix this, to get this database to go, what I got to do is drop that procedure, right? But I didn't want to have to restart my whole process again, but I'm going to have to, because there's no option to go back or next. It was all or nothing. So I have to hit close. I'm going to make sure I choose my on-prem database. I'm going to do new query, and I'm going to drop that object because we know it's not going to go. So it's gone. We just minimize a few things here so we have the attention, right? So now we're going to do this again. We're going to go through the whole process once more. And if you're like me, it's like, well, that stinks. I have to do this all over again. You probably are like, well, we don't have all the time to do this because sometimes it takes 20 minutes for it to get that screen up. Next. And once again, it's going to look to make sure it can connect. It's going to make sure that location exists. It's going to check space. It's going to make sure I can actually create databases to Azure. It's also checking my permissions level. And there we go. Again, we already covered this before, so we're going to hit finish. And this time, it's going to start going, right? So it's, if we just read right down through here, it's extracting the schema from my database. It's getting references in the schema model. It's validating my schema. Then it's going to take all my data out, export it. It's going to process all my tables. Then it creates its deployment plan. I don't know exactly what that means, but in my back of my mind, I'm thinking that what it's doing is it's creating a PowerShell script on the fly to create the deployment to actually create the database up there. If we refresh my database as a service instance, we might be able to see the Nintendo database exists. There it is. But the deployment is still ongoing. So what this is telling me is that it's made the database. So now it's probably going through creating the tables and pushing the data. It's restoring my database to Azure, which is cool. That was pretty simple, right? And once it's done, well, the problem is going to become, well, we need that procedure back. I'm going to show you a trick on how to make that procedure run in an Azure environment once this gets done. Sometimes it takes a little longer. Sometimes it's done pretty quick. This doesn't always depend on your network speed. This can depend on how busy the Azure host is as well. So I'm deploying the Azure SQL database, I'm deploying the East US2, which is a very, very popular data center for Azure. So depending on how much network traffic is going in there, compared to what host I'm on, it can take a little bit longer. When I did this before, it wasn't taking this long, but it should be done here relatively quick because, again, it was just a 19 meg database. And here we go. It's going to start processing through, and it's done. If you have a larger database, this process takes a little longer, and it will show you, like, okay, we're done with this table. We're done with this table. I'm going to hit close here because our operation's done, right? So, well, it's not done. We got to create our procedure, right? I'm going to open up a script that I have for this demo. What we're going to do here is we're going to create what are things called an external table with an external data source, right? And for that purpose, what I want to do is I need to have some things in place first. I want to encrypt my database with a master key. And then I'm going to create a database scoped credential. This credential is just a scoped copy of my actual login, right? I did minimize the secret part because that's the actual password, and I don't want anybody to see that. So I'm going to run this part. Okay, so it ran against my Nintendo database. So I have this part created. The next part's going to be is I got to create my data source in my external table. If you're familiar with linked servers, this is essentially making a linked server between my two databases, right? It sounds silly to say I'm making a linked server connection between databases rather than between servers, but that's essentially what we're doing. So when I create an external data source, I like to try to keep it uniform with, I usually use the name of the database first, and then I choose the name of the table that the external source is going to be for. It's an RDBaas. This is the location of where it's going to be. It doesn't have to be on the same server. It could be on a different instance. Here's my database name, and I'm going to use the credential that I created above. So I'm going to run this. And now I should have my data source under my Nintendo database. And there it is. So there's not much I can do with that right now because it doesn't have anything else. This is just creating the source. What I need to put in my source is I need to put an external table. So you'll see my table. To get this, all I did was I right-clicked on my table on-prem. And just to show you. Did that script table, create to, new query window. And I just copied this. Now, with the copy we're doing, we don't want the identity because it doesn't matter, right? We're just calling to it. We're not actually inserting to it. So I didn't copy the identity part. So we're going to execute that part. Now, to validate this works, what I'm going to do is go under Tables of my Nintendo database on Azure. And go to External Tables, and there's my Sega_Sega Genesis. To validate that everything was working properly, I need to make sure that I can query data from there. So let's just do select top one star from Sega_Sega Genesis. And so it takes a little bit of time because it has to authenticate through both. We should get a result back here. As long as we get a result back here, we know that the authentication works and that the external creations work just fine. Again, these are very small databases. The DTUs are only 5 to 10 DTUs a piece. It's probably running into some of those limits, but we should be getting something back anytime now to let us know that the creations worked. And there we are. So we got data back. I know my external creations worked. So we'll minimize that down. We can get rid of that. So now it comes back to the procedure. So to make my procedure work, all I really had to do was just update my location, where I'm selecting from, right? So before it was sega.dbo.segagenesis. Well, since I can't cross database query that way, what I got to do is name that from the external table name, right? So if I create this, right, now it works. So now I can execute that procedure and it should work the same way it worked when it was on-prem. We're going to give it a few seconds here. We're going to hit OK to this. And there we go. It worked just fine. Now I know that my external creations are working. I don't have to, do anything else special. This worked. So I hope you enjoyed these. I really do. If you do have any questions, we will have contact information at the end. Chris, we have about 11 minutes for questions. If you and Kelly have any, now's the time. I'll turn the controls back over to you.
Okay, good deal, Jim. Okay, Kelly, can you see my screen and how do I sound?
Yes, your screen and your sound is good.
Good deal. Thank you. Jim, I really appreciate the demos, and RDX doesn't profess to be an expert in all things cloud. The benefit we provide is we have a large customer base, and many of our clients use cloud database systems. We are, above all, a learning organization, and our collective egos don't prevent us from saying that we teach, but we also learn from our customers. We have customers that range from bleeding edge, latest technology, to those that have the strategy of yesterday's technology tomorrow. That range of strategies allows us to learn many different ways of doing things, how not to do things, and the pros and cons of many different architectures and tech stack combinations. So this wraps up this month's presentation. As I recommended earlier, mark your calendars for RDX's next Insight Series presentation. On Thursday, May 24th, Jim Donahoe and I will be presenting Azure SQL Managed Instances. Microsoft is stating that managed instances will allow shops to lift and shift on-premises databases to Azure DBaas with minimal to no changes. You can continue to use instance-level capabilities without changing your application design. The timing of the webinar will be dependent on Microsoft's preview program availability. If we're unable to complete our testing in May, we will schedule the presentation for June. Also send me an email to join our newsletter. You don't have to be a customer to receive it. I have my email in the upper right-hand corner of this slide. Kelly, do we have any questions from today's webinar?
Yes, we do have some. I'll start with this one. It's for you, Jim. It states, how can you control the version of SQL Server? Will it be increased automatically, and will your application somehow have to keep up?
I'm assuming you mean the SQL version that's on Azure Database. You can request, you can make a request to not have your version be upgraded automatically. However, just remember, Microsoft is using a cloud-first strategy that they're going to upgrade Azure first before they do any on-prem or migrations or installs. So if your app is one that depends on a certain version, it makes it a little tougher. But again, when you create your server, you can specify what version you want it on, or you can have your database only be used in that compatibility. That's a good question.
And we did have another one for you, Jim, asking how long it takes to migrate a 500 gigabyte database.
So as a DBA, one of my favorite answers, and favorite answers for most DBAs, is it depends. That's always going to depend on several things. One, depends on your bandwidth for your machine or for your environment. Two, it depends on how many objects. You could have a 500 gig database, but it's spread out over thousands of objects, or you could have a 500 gig database that's spread out over like 20 objects. It really depends, and that's always why you want to do that migration assistant method first, because you can always say, like, okay, well, I know this table is pretty large. Let me get the other ones up there first, and then work on that one. That's one of the beauties of using it that way. Good question.
Thanks. So we have another one that just came in. Is there a method or tool to help eliminate the amount of time the deployment will take to upload a backpack without doing the upload?
None that I'm really familiar with. I usually like to stay within the Microsoft stack for uploading or migrating anything to the Azure stack, just because I know if Microsoft's recommending it, they probably put it through tons of tests, and I usually would hope so. But I only stuck with the 3 tools I've showed you today. I'm sure there might be something out there, but as far as my uses, I've only used the 3 methods I've shown today.
And I have one more for you, Jim. Can you replicate from Azure to on-prem?
Unfortunately not. Azure, it's actually a really good point, and thank you for whoever asked that, is that Azure can only be used as a subscriber. It cannot be a publisher. Azure SQL Database cannot be the publisher, I should say. If you're using an infrastructure as a service solution, yes, you can replicate from there down to on-prem. But with Azure SQL Database, you cannot make it a publisher. It can only be a subscriber.
Okay. Thank you very much, Jim. Those are all of the questions I have.
Well, thank you, everybody, for attending today's webinar, and have a great weekend. So thank you very much, and we'll see everybody next month. Thanks again. Bye-bye.
Thank you, everyone.